a static variable declaration here, which is in the class, and the scope of that one will extend basically from the point of its original declaration to the end of the enclosing curly braces. So that variable y will be visible throughout the entire class. And indeed, if we take a look at this, we can see that there we have code inside the method that is using the variable y to assign to the value of x. The next variable is this variable int x, defined inside the main method. The declaration starts the scope that it's declared in, and the end of the enclosing curly brace defines the end of that scope. Because of that, we can refer to x down here, and we can refer to x anywhere else inside this method, lots of places. The next thing we notice is that we also have a variable declared inside this block. So we have this block that serves no obvious purpose other than for illustration, and inside it we declare actually two variables, an int j and an int d. And both of those are available in exactly the same way. In the case of j, from the point at which it's declared to the end of the enclosing block. In the case of d, it's obviously declared a little later, so it doesn't come into scope quite as soon. But here we can see that we can refer to j in here just as well as we can x. Next, let's take a look at some of the things that are not in scope. So in this case, you'll see we've got some lines commented out here. If I bring these back, if I try to refer to d before it has been declared, even though it's in the same block, you can see that the compiler is complaining. There's an underline there, and if we hover over this, it says, cannot find symbol. It's not in scope. Similarly, we'll comment that one back out. We'll move down to here and uncomment these two lines. Neither j nor d, both of which were declared inside the block, are visible after the close of the block that they were declared in. So because we are beyond the closing curly brace from the block that they were declared in, we can no longer see either of those variables. So that's the basic idea. The essence of the scope of a simple variable is that it begins at its declaration and it ends at the closing curly brace of the block that it was declared in. But there are some exceptions. Those are coming up next. So in this code you can see I've set up a very similar set of circumstances. We have, first of all, a for loop here. And you can see that in that for loop I declare a variable I. In this case, just to illustrate there's another variation on the theme, I did not create a block. So you'll notice there's no opening curly brace there. In this case, however, it's an implied curly brace, as though it were declared here and closed right after the single statement that is subordinate to that loop. Because of that, you'll see that we can refer to the variable I in the statement that is immediately after the loop statement, as well as various places inside the loop. So there's the declaration. There we're using it in a comparison expression, and there we're using an increment operation on it. There we're using it, in effect, inside the body of the loop. However, this here, immediately afterwards, if we see what the compiler does, if we ask it to actually use that statement, notice that as soon as I uncomment it, the compiler has underlined it with a little squiggly red line, and the error says cannot find symbol, variable I. In other words, the scope of I starts right there at the declaration and ends with the end of that single statement. Let's take a look at the second version. In this case, what I have done is to create essentially the same loop. You can see here we have the same basic loop for int I equals 0, I less than 10, I plus plus. What's particularly interesting about that, perhaps, is I have redeclared a variable I. This is the same name as we used before, but this doesn't upset the compiler because it doesn't count as redeclaring it, because the previous version was out of scope. So we have no problem there. This time we do have curly braces, and the curly braces behave much more like we would typically expect, there and there, and what we find is that the scope of our variable I is visible in its declaration, the two pieces of the loop that follow it, inside the loop, and indeed we can do multiple things with it inside the loop. So this time we can have more than one line using the variable I, here and here, where previously we could only use it in the one line immediately following. Again, if I let the compiler tell us what's going on, let's just comment out the line that didn't work before. If we uncomment this one, you see again that the compiler is objecting to the variable I here, and if we were to look at the complaint that the compiler produces, we can see that it says it cannot find the variable, cannot find the symbol. So in this case, it's a little bit nearer to what we're used to. The bulk of that variable is contained within the curly braces. Anyway, the final observation is down here in this method. Here you can see that the variable I is declared in effect as part of the method declaration itself. And even though that is outside the curly braces, it is still visible inside. But if we tried to use that variable further down, if we were to write some code that came after that closing curly brace, we would not be able to.